Good day everyone. Our topic for the midterm project is the general amplitude modulation process. So what is the amplitude modulation? Amplitude or AM, it is known as a type of modulation used in radio broadcast for two-way radio communication and broadcasting purposes. Amplitude modulation process is the process in which the wave signal is transmitted by modulating the amplitude of the signal and is commonly used in transmitting a piece of information through a radio carrier wave. The modulating signals or the message signal is expressed by formula m of t is equals am cos times 2 pi fmt. For the carrier signal is expressed by the formula c of t is equals to ac cos times 2 pi fct. Next is the equation for the amplitude modulation wave is s of t is equals to bracket ac plus am cos times 2 pi fmt cos times 2 pi fct. For the formula of modulation index is micro is equals am over ac.
Now, to continue the formula of the amplitude modulation, for us to determine the maximum and minimum amplitude of the modulated signal, we will use the following formula. For maximum amplitude, we can use AC plus AM and minimum amplitude to AC minus AM. And from the maximum and minimum amplitude of modulated formula, we can have A max minus A min over A max plus A min. And for us to get the bandwidth, we only have to subtract the minimum frequency minus maximum frequency, where F max is equivalent to FC plus FM and F min is equivalent to FC minus FM. So those formula, we can have another formula for bandwidth, which is bandwidth equals to close open parenthesis of FC plus FM minus FC minus FM, so we can get 2FM.
To get the power AM waves, just add the carrier power, upper sideband, and lower sideband. To get the carrier power, use the derived formula amplitude carrier squared divided by 2R. To get upper sideband power, use the derived formula amplitude carrier squared multiplied to module index squared all over or divided by 8R. And same as lower sideband. By adding the three formula, derive it. AM waves is equal to carrier power multiplied to 1 plus modulation index squared divided by 2.
Now, we can solve for the following problem. A modulating signal AM is equals to 3 cosine times 2 pi times 5 times 10t is amplitude modulated with a carrier signal. AC is equals to 7 cosine times 2 pi times 10 squared t. Find the modulation index, percentage of modulation, the carrier power, the power required for transmitting AM wave, total sideband power, and the bandwidth of AM wave, assuming 7 ohms resistance. The following are the given. To get the modulation index, we can use the following formula. Mu is equals to AM over AC, where mu is equals to modulation index. Inputting the value 3 over 7, we can get 0.43. To get the percentage of modulation, we can multiply the modulation index to 100%, so 0.43 times 100 is equals to 43%.
Next is we're gonna solve for the carrier power. So the formula for the carrier power is equal to AC squared over 2R. So 7 squared over 2 times 7. So now our PC is equals to 3.5 watts. So next we're gonna solve for the power required for transmitting AM wave. For the formula of this is PT is equals to 3.5, which is our PC times 1 plus 0.43 squared over 2. So our PT now is 3.8 watts.
Next is kunin naman natin yung sideband power. The formula for sideband power is equals to carrier power times modulation index squared divided by 2. So, ang carrier power natin is 3.5 times 0.43 squared divided by 2. So, ang sideband power natin is equals to 323.58 milliwatts. Next is kunin naman natin yung bandwidth of AM wave. Ang formula natin for bandwidth is 2 times modulating signal frequency, which is 2 times 5. So, ang bandwidth natin is 10 Hz.
To simulate a given problem, we use Scilab. We create a simple program just to show how does the modulation work. Once I run this, there's another message on the other window asking to input the value of modulation or the message signals, which is 3. Then another message asking to input the value of carrier signal, which is 7. And it will automatically calculate the modulation index. And there will be another window going to pop out showing the graphical representation of all those signals. On the upper part is the message signal. On the middle part is the carrier signal. And at the bottom part is the modulated signals. And that's it, how we simulate this problem using the Scilab. Thank you.